All right, so are you ready to unlock some secrets of Feature Engine?
Ooh, secrets. I like it.
It looks like we're diving deep into how to prepare data for machine learning. We're going to break down how this Python library can help you sculpt your data into something really remarkable.
Yeah, what's so fascinating about Feature Engine is it's not just about cleaning the data, it's about transforming it strategically. Like to unlock insights that otherwise wouldn't be visible. Like you're taking a lump of clay and molding it into a masterpiece.
Yeah, I've always thought of data as kind of this raw, untamed beast. And Feature Engine is like this toolbox full of gadgets and gizmos that can really tame it, even the most unruly data sets.
Exactly. And the beauty of Feature Engine is that it acts as like this central library for all these different transformation tools or transformers, as they're called. And it integrates directly with scikit-learn pipelines, which is essential for building really smooth and efficient machine learning workflows.
Okay, let's unpack that a little bit. So we keep hearing about these transformers. What exactly are they? And how do they work?
Okay, so imagine a workshop and each transformer is a specialized tool. Some tools help you fill in those pesky missing values. Others smooth out those weird outliers that can really mess up your analysis. And then some will even help you transform those categories into numbers, because remember, machines love crunching numbers.
They're number crunching fiends. But that makes sense because a lot of real world data comes in the form of categories, colors, sizes, types. We need a way to make that understandable for our machine learning models.
Yeah. Exactly. And the really cool thing about these transformers is that they're not just applying some fixed rule to your data, they're actually learning from it first. They're analyzing the patterns in the data,
Yeah.
the distributions, and then they're using that knowledge to actually make the
So
transformations.
it's like giving your data a tailor-made suit instead of one of those generic off-the-rack outfits.
I like that analogy. That's a good one. It's about finding the best fit for your data, and it helps your models make more accurate and insightful predictions.
So it's not just about making the data look pretty for the models. It's about revealing the story that's hidden within the data, right?
Precisely. It's finding the best representation of your data to allow your models to extract really meaningful patterns and relationships.
Okay, this is already blowing my mind. I'm starting to realize that feature engineering is more than just like a step in the machine learning process. It's an art form in itself.
It is. And like any art form, it requires the right tools. That's where Feature Engine comes in. It provides you with this really incredible toolbox to help you craft that perfect data representation.
So walk me through this toolbox. What are some of the key challenges that we face when we're preparing data? And what kind of tools does Feature Engine provide to kind of tackle those challenges?
Well, let's start with a problem I think everyone faces: missing data. It's like a puzzle with some pieces missing, right? Feature Engine offers a set of tools called imputers to fill in those gaps.
Yeah, we've all been there staring at a spreadsheet with missing values, wondering what to do.
Exactly, and the best way to deal with them depends on the situation. For instance, you've got your mean median imputer. So imagine you have a data set of penguins, and some of them are missing their bill lengths. The mean median imputer can just fill in those gaps using the average or the median bill length from the other penguins.
That makes sense, but what if you want to use a specific number instead of just the average? Like, what if you know something about the data that the model doesn't?
That's where the arbitrary number imputer comes in. It's all about applying your domain expertise. Let's say you're working with age data, and you know that any missing value likely represents someone around 25 years old. You can use this imputer to fill those gaps with the number 25.
Okay, so it's like you're using your knowledge of the real world to make the data even better.
Precisely. Now, what about categorical variables? Do you fill missing categories with the placeholder like missing? Or do you use the most frequent category? That's where the categorical imputer comes in. It lets you choose the best strategy that makes the most sense for your data. And of course, there's always the drop missing data transformer, which is like the delete button of data cleaning.
That one sounds a bit dangerous. I feel like I'd be afraid to accidentally delete valuable data.
Yeah, it is a last resort. You definitely want to be careful with that one and only use it when absolutely necessary.
So we've handled missing values. What's next? What about those pesky outliers? Those always seem to mess things up.
Outliers can be troublemakers, that's for sure. But Feature Engine has some pretty effective tools for taming those outliers. Let's talk about the Winsorizer. Remember the Titanic dataset?
Oh, a classic. Who could forget the Titanic dataset?
Right. Now imagine the fare variable. You're going to have some extremely high fares in there for the luxury suites. The Winsorizer can help you cap those outliers. It'll take the most extreme values and just kind of pull them in a bit so they're closer to the rest of the data.
So it's not deleting those outliers. It's just like giving them a little trim.
Exactly. And what's really cool is that you can actually see the impact visually. Feature Engine lets you create these before and after plots that show you how the distribution changes after applying the Windsorizer.
Visualizations are always super helpful. I'm a visual learner myself. So are there other ways to handle outliers?
Absolutely. The arbitrary outlier capper is similar to that arbitrary imputer. It lets you set specific caps based on your understanding of the data. So if you decide that any fare above, say, $500 is unrealistic, you can cap it right there. And then, of course, there's the outlier trimmer, which, like that drop missing data transformer, is a bit more extreme. It just removes outliers entirely. But again, you've got to be careful with this one as you might lose some valuable information.
It's like walking a tightrope between cleaning up your data and then preserving the integrity of it.
Exactly. That's the beauty of feature engineering. It gives you the tools to make those decisions strategically and thoughtfully.
Okay, so we've tackled missing data, outliers. What other tricks does Feature Engine have up its sleeve?
Well, remember how we said that machines love numbers? But a lot of data comes in the form of categories.
Yeah, like those colors, sizes, types we were talking about.
Exactly. That's where encoding comes in. And Feature Engine offers several encoding techniques. One of the most popular is one-hot encoder. Let's say you have a color variable with categories like yellow, blue, and green.
Okay, I'm visualizing it.
This encoder will transform those colors into a numerical representation. It creates separate columns for each color, yellow, blue, green. And if a data point is blue, it gets a 1 in the blue column, and then zeros in the other two.
So instead of the model seeing blue, it sees 0, 1, 0.
Precisely. And to avoid redundant information, you can even use what's called the drop last true option. It's like saying, hey, if it's not yellow or blue, it must be green.
Clever. So what happens when the order of the categories actually matters?
Excellent question. That's when we turn to the ordinal encoder. It assigns numbers to categories based on a perceived order. So for example, if you're encoding clothing sizes, small, medium, large, the order clearly matters.
Right, the small is definitely smaller than a large.
Exactly. But what about something like colors? Is there a true order there, or is it arbitrary?
Ooh. It's like those arbitrary versus ordered choices are little puzzles themselves. But that's what makes feature engineering so interesting. It's not just about applying formulas. It's about really understanding the nuances of your data.
You got it. And that understanding is actually what allows you to make those really strategic choices about which transformations to apply.
This is fascinating. We've covered a lot of ground already. Imputing missing values, taming outliers, and encoding categorical variables. What about numerical transformations? I feel like those could get really complicated.
They can, but Feature Engine makes it surprisingly approachable, and that's actually what we'll delve into next.
All right, so we're about to enter the realm of numerical transformations. What kind of sorcery are we talking about here? Sounds a bit intimidating.
Don't worry, Feature Engine keeps things fairly painless, even when we're dealing with numbers. This is where we get to play with different mathematical functions to reshape our data and make it easier for our models to digest. You know, it's like we're seasoning and prepping those ingredients to really bring out the flavor.
Okay, so instead of chopping and dicing, we're adding a pinch of logarithm and a dash of reciprocal.
You got it. We've got transformers like the log transformer, reciprocal transformer, power transformer, even a Box-Cox transformer, and a Yo-Johnson transformer.
Okay, you lost me at Box-Cox.
Yeah.
But I get the general idea. We're using math to like massage our data into a more model-friendly form. But how do we know which transformation to use? It seems like there are so many options.
Well, that's where Feature Engine really shines, you know? Remember how we talked about it being so useful for both research and production? It includes tools that help you explore and visualize the effects of different transformations. So in your research phase, you can experiment with these different transformations. And because Feature Engine returns that data in a format that's compatible with scikit-learn, transitioning that code into a production pipeline is seamless. You don't have to reinvent the wheel.
Oh, so it's like having this testing ground for our data transformations. We can try different things and see what works best without messing up our main data set.
Exactly. Think of the feature engineering analysis function. It's like having a really powerful magnifying glass. It lets you apply different transformations to a variable, like that fare variable from the Titanic dataset we were talking about, and visually compare the results. You can see firsthand how each transformation changes that data's shape, and then you can decide which one best prepares your data for modeling.
That's amazing. It's like we can try on different transformations and see which one just like fits our data best. But what if none of the pre-built transformers quite fit our needs? What if we have like a really unique situation that requires a custom solution?
That, my friend, is where we enter the realm of ultimate data wizardry. creating your own custom transformers.
Wait, I can code my own data transformations. I thought that was only for like the machine learning gurus out there.
Not at all. Feature Engine makes it surprisingly approachable. Basically, you create a new Python class and use a bit of object-oriented programming magic. You inherit from two key building blocks, Base Estimator and Transformer Mixin. These provide the structure and methods needed for your custom transformer to seamlessly integrate into a scikit-learn pipeline.
Okay, that sounds a bit technical, but still fascinating.
Yeah.
Can you give me an example of what this custom transformer creation process looks like?
Absolutely. Remember that my custom transformer formula imputation example from your notes? We'll pretend that specific functionality doesn't already exist in Feature Engine just to illustrate the process. So you define the variables that your transformer is going to handle, you write the fit method, that's where your transformer learns from the data, and then you write the transform method, which actually applies the transformation to new data.
And what about the convert uppercase example? That one seemed much more simple.
Ah, yes. That one just highlights how straightforward custom transformers can be. You don't always need a complex fit method. Sometimes you just need to apply a simple function to your data. In that example, we're simply converting strings to uppercase. But you can imagine all sorts of custom transformations that you could create. You could write a transformer to standardize units, extract specific information from text, or even engineer entirely new features based on your domain knowledge.
So if I wanted to, I could create a transformer that replaces all missing values with my lucky number.
Well, while that specific use case might not be the most practical, you've hit on the incredible flexibility that custom transformers provide. You're no longer limited to those pre-built tools. You can tailor your data transformations to your exact needs.
That opens up a world of possibilities. But before we get too carried away crafting custom transformers, you mentioned something about like power-ups for data cleaning and feature engineering. What were those again?
Right. We can't forget about those. Feature Engine also provides some incredibly useful functions to enhance your workflow. Two of these are data cleaning effect, and you guessed it, feature engineering analysis, which you've already touched upon a bit.
Okay, remind me what's so special about data cleaning effect.
Imagine having X-ray vision for your data cleaning process. That's what data cleaning effect provides. It lets you actually visualize the impact of your data cleaning decisions. Let's say you've decided to impute missing ages in your data set with the median value. This function will generate a before and after view of your age distribution, so you can clearly see the effect of your imputation strategy. No more second guessing.
That's incredibly helpful. I like the idea of having that visual confirmation that I'm actually improving the data.
Exactly. And then there's feature engineering analysis, your ultimate exploration tool for those numerical transformations that we were discussing earlier. It lets you try out different transformers on your data without having to write tons of code.
So it's like a testing ground for those mathematical transformations. We can see how each one affects the data before we actually commit to a specific approach.
Precisely. You can test out different approaches to handling outliers, like comparing the Windsorizer to the outlier trimmer, or experiment with different encoding schemes for your categorical variables, all within this really structured and efficient framework.
This is incredible. Feature Engine really does provide like a comprehensive toolbox for data preparation.
Yeah.
It's like we've gone from using a rusty screwdriver to having like a state-of-the-art workshop at our fingertips.
That's a great analogy. And speaking of having the right tools, the real power of Feature Engine lies not just in its individual components, but in how they all work together seamlessly. This brings us back to the concept of pipelines. Remember those?
Yes, pipelines. We briefly touched upon them earlier,
Yeah.
but I'm ready to dive deeper. How do they fit into this whole data preparation process? Pipelines. They sound like the secret sauce that ties everything together.
They're more like the well-organized assembly line of the data factory. Think of each transformer we talked about as a station on that assembly line. Raw data enters the pipeline, and as it moves along, it gets cleaned, it gets transformed, and it's shaped into this like beautiful finished product ready for your machine learning model to use.
Okay, that's a way cooler image than just a sauce. So instead of like manually applying each transformer one by one, we can create a pipeline that does it all for us automatically.
Exactly. And the best part is that pipelines not only streamline your workflow, they also make your code much more robust and reproducible. So if you need to apply the same set of transformations to a different data set, you can simply reuse that same pipeline without having to rewrite all the code.
That's a huge time saver.
Yeah.
And I imagine it helps prevent errors too.
Huh.
No more accidentally applying a transformation in the wrong order.
Exactly. Pipelines enforce a very specific order of operations, which is crucial for consistent and reliable results. This is especially important when you're transitioning from research to production, as it ensures that your data preprocessing steps are always executed in the correct sequence.
So pipelines are like the conductors of our data orchestra, making sure that all the instruments are playing in harmony and at the right time.
I love that analogy. They bring order and structure to what could otherwise be a very chaotic process.
Thinking back to when we first started talking about Feature Engine, I was a bit overwhelmed by all the different transformers and techniques, but now I'm starting to see how it all fits together. It's like we've been on this incredible journey from feeling intimidated by data to
Yeah.
feeling empowered to shape and mold it to our will.
And that's exactly what Feature Engine allows you to do. It empowers you to take control of your data, to unlock its hidden potential, and to create those truly insightful machine learning models. It's not just about cleaning up messy data, it's about transforming data into knowledge.
I couldn't have put it better myself. This whole deep dive has been so eye-opening. It's amazing how much thought and strategy goes into preparing data for machine learning. I feel like we've only just scratched the surface of what's
So,
possible.
Dan, that's the beauty of it. There's always more to learn, more to explore, and more creative ways to prepare your data for the specific challenges that you're trying to solve.
As we wrap up this deep dive, I'm left with this thought. If we can create custom transformers to tackle unique data challenges, imagine the possibilities. What incredible insights could we unlock if we continue to push the boundaries of feature engineering?
That's a fantastic question, and it's one that data scientists all over the world are grappling with every day. The potential is limitless. Feature engineering isn't just about preparing data for models, it's about shaping the future of how we extract knowledge and understanding from the information that surrounds us.
That's a really powerful way to put it. And on that note, I think we've reached the end of our deep dive into Feature Engine. Thanks for joining us on this incredible journey of data transformation and discovery. Until next time.